Welcome to Chapter 11, Part 2, The Dual Nature of Light. I know we covered light, wavelength, frequencies, the spectrum, the whole thing, and I said, truly, this has something to do with chemistry. It's not just physics. And all of this boils down to the electron. But before I talk about the electron, I have to talk about light. And I know this isn't making a lot of sense, but trust me, it will all come together. The first question of early Einstein's time, he was about 15, there was this big argument, is light a wave or a particle? You see, if light was a particle, like little things coming out of a light bulb, if it hit a barrier, the shadow would go straight through, just like this. Well, you and I both know that if light, say your bedroom door is only open part way, the light from the hallway doesn't just shadow out in a straight line, it seems to bend around that barrier. So the idea at that time was, hey, light is definitely a wave. No question about it. Light's a wave. On it, smaller wavelength, you're going to get more. See, if it's a smaller wavelength, well, that would carry more of these guys. So these guys would all enter, that's funny, hit and enter into this metal more quickly and eject more electrons. And if you change the intensity, made a brighter light, that's why it doesn't change the number of photons that hit. And based on this conclusion, Einstein said light definitely contains particle-like behaviors, which was really mind-blowing for all of the physicists at the time. In fact, at the time of Einstein, students were discouraged from entering physics because it was believed we already knew everything there was to know about physics, thanks to Sir Isaac Newton, and there was no need to study science anymore, well, at least physics, until this idea came along and blew everybody's minds because, oh my gosh, all of a sudden we've got light acting as a particle. The end result to the idea of light being a wave or a particle, by the way, Einstein was 19 when he proposed this, and yes, he won his first Nobel Peace Prize for that. But the essential idea is that light does behave as a wave. But light also can act as a particle. And these particles are called photons. Photons, it was Einstein's word. The prefix photo means light. And I like to visualize photons on waves like this. So here you have your light wave as we've traditionally viewed light, and it's carrying these little packets of energy called photons. The big idea behind all of this, is light a particle or is light a wave? Well, to be honest, it's both. Light is both a wave and a particle, which is why we say it has the dual nature of light. Light is a wave. Do you see the word wave in here? Do you see the word particle? That's one of the reasons I like this slide, is it says light is both a wave and a particle. Up next, we're going to discuss de Broglie, and I know I said that the American way, the electron, and what all this has to do with the electron.